Today we'll be dealing on power series and its application in solving ordinary differential equation. So the power series we are going to deal today is going to be Taylor series and Maclaurin series. Taylor series is given by the equation y of x is equals to summation of from n equals 0 to infinity x minus x naught raised to the power of n divided by n factorial y to the n x naught. So this is Taylor series. So in a situation where x naught is equals to 0, that will give you Maclaurin series. So this is Taylor. Then if y of x is equals to summation of from n equals 0 to infinity x raised to the power of n divided by n factorial y of n of 0, this is Maclaurin. So as I was explaining earlier, the difference between the Taylor and the Maclaurin series is that in Taylor series, when you make x naught to be equal to 0, then you get Maclaurin series. So let's expand the Taylor series. Let's write up to the fourth or the fifth term of the Taylor series. So expanding the Taylor series, we have that the y of x is equals to, now expanding, when n is equals to 0. So when n is equals to 0, you come to this place, and wherever you see n, you put 0. So if I put n equals 0 here, n raised to the power of 0 is going to give me 1. And then when I put n equals 0 in n factorial, if you put n equals 0, 0 factorial is going to give you 1. So, but when you come to this place, the n here is different from the n here, because the n here is not talking about power, it's talking about differential. Okay, so the differential of y raised to the power of 0 will just give you y. So what you just have here is normal y, and of course the x naught. Okay, the difference between the n here and the n here is that this one is power, while this other n is talking about differential. So this is the first term of the series when n is equals to 0. Now when n is equal to 1, it will increase from 0 to 1. So when n is equals to 1, so when you put 1 here, and of course 1 here, 1 factorial is going to give you 1, and of course n raised to the power of 1 is going to give you that same stuff. So we have that x minus x naught. Okay, then when you come to this place, it's not going to be y raised to the power of 1, it's going to be y prime, because I told you earlier that the n here is not talking about power, it's talking about differential. So we're going to have y prime of x naught. Now for the third term, that is when n is equals to 2. So when n is equals to 2, you have that. Remember, this one is talking about power, this one is talking about power as well. So you have that x minus x naught raised to the power of 2 divided by 2 factorial. Then, of course, the y here is not, the n here is not talking about power, it's talking about differential. So you have y of the second differential of x naught. Then for the fourth term, we're going to have x minus x naught raised to the power of 3 divided by 3 factorial y to the third prime of x naught. This series continues to infinity. So in the case of where you want to expand out of the Maclaurin, wherever you see x naught, you are going to impute 0. So that's the difference between Maclaurin and Taylor. So I would solve questions to elaborate more on how to use this series expansion to solve ordinary differential equation. So from the first question that I have here, So the question says that find the first 5 terms in the series of solution of y prime prime plus xy prime plus y minus x squared y is equals to x, with y of 0 equals a and y prime of 0 equals b. So what you're going to do here is first of all write down the equation that you were given, solution. So writing down the equation, we have that y prime prime plus xy prime plus 1 minus x squared y is equals to x, under the condition that y of 0 is going to give me a and y prime of 0 is going to give me b. So the first thing you're going to do in this expansion is to make the highest differential the subject of the formula. So make the highest differential the subject of the formula, and if you can check from this question, the highest differential is y to the second differential. So making it the subject of the formula, we have that the y prime prime is equals to x minus xy prime plus minus 1 minus s squared of y. So I would advise you to expand this in case you have something like this. So try to expand to have a more understandable solution. So you have that x minus xy prime minus y plus x squared y. So this is what we have. So when you've made your second differential, sorry, your highest differential thing, subject of the formula. So you need to use these conditions to impute into this equation to get your y prime prime. So looking at the conditions, you see that your x naught is equals to 0. Your x naught is equals to 0. So each term is equals to 0. Each time you are given any initial condition, look at what is in the input of the y. Look at what is at the input. That will be the number or the figure you are going to use for your x. Okay, so the situation when we have the y prime prime of 0. The reason why I'm using y prime prime of 0 is looking at the initial conditions. It's talking about that the inputs. Okay, let's do some comparison. If you look at the series expansion of the Taylor series, you see that we have y of x naught, y prime of x naught, y prime prime of x naught. Okay, so if you try to compare this and this, you see that of course x naught is equals to 0. So we are going to use that to impute here. So in this case, wherever you see x should be the input you got from your initial condition. So from here now, x is going to be 0 minus x, of course, is going to be 0 times what's our y prime? Our y prime will be what was given here. So that will be y prime, of course, b. So we have b minus our y. So our y is going to be this one, which is the y of 0, and actually it's going to give us a plus, you have x is actually 0 from here. So you have 0 squared times y, which is a. So by imputation, we know that everything is going to give us negative a. So we've gotten our y prime prime of 0. So since the series said that we should find out to the 5th term, so let's solve for that. So now to get the third differential, you need to look at what you have from your second differential. So differentiate everything out of your second differential, that will give you your third differential. Now when you differentiate the second differential, you're going to have the third differential, okay? So equal to when you differentiate x with respect to y, you're going to have 1. So when you differentiate x, you're going to have 1. Now, when you want to differentiate anyone that has a combination of x and y, you need to consider product rule. Okay, so you are going to take them as products. So how are you going to do it? First of all, bring out the sign that is allocated to the product you want to differentiate. So which is negative. Open a bracket. So what I want you to do is that we are going to hold one of the products and differentiate the other. And afterwards, you hold the other one and still differentiate the first one. So let's assume I want to hold x first. So I'm going to differentiate y. So holding x first and differentiating y. Since y is to the first differential, if I differentiate it again, I'm going to get y to the second differential. Plus holding the y to the first differential, y to the first differential, and differentiating x. If I differentiate x with respect to y, I'm going to have 1 minus. Now, if you differentiate y, since it's just y, so you're going to have y to the first differential. What you need to note about the differentiation of y is that whenever you have y to the second differential, you're going to, when you differentiate to the next one, you're going to have to the third. And of course, this one that was to the 0th differential increase to the first differential. So that's how to differentiate y's. So then for the last one, of course, bring out your sign and open a bracket. So hold the first x and differentiate the second y. So holding the first x gives me x squared, and differentiating this y gives me y prime. Plus, I'm going to hold my y, of course, because I've held this one to differentiate this. So I'm going to hold this to differentiate this one. So holding y to differentiate x, holding y to differentiate x. Now if I differentiate x squared, differentiate x squared is going to give me 2x. It's going to give me 2x. So bringing out my whole solution gives me 1 minus xy prime minus y prime minus y prime plus x squared y prime. Of course, 2x times y will give me 2xy. Okay, so since we have gotten the third differential, the next thing I'm going to do is to apply your initial conditions as well to this third differential. So applying our initial conditions, which gives us y to the third differential of 0 is equals to 1 minus, we know that x from here is already 0, so that will give me 0 times our y prime prime. What's our y prime prime of x? We have already gotten it as negative a, so I'm going to have negative a minus, we have our y prime. What's our y prime? Y prime is b, so it's going to be negative b, and of course negative b. So plus our x is 0 squared times our y prime is b, so our y prime is b, plus 2 times our x is 0 and our y is a. So bringing out the whole solutions from here, we know that all these turns to 0. We are left with 1 minus 2b. So I've gotten up to the fourth term, so I'm going to do the last term as the question implies. So in the last term, we will have to differentiate y to the fourth power. So y to the fourth differential. So differentiate y to the fourth differential, you are going to look at what you have at your third differential. So whatever you have at your third differential, you're going to differentiate it to have your fourth differential. So differentiating what you have, and of course, as I told you earlier, when you differentiate the third differential, you're going to have the fourth differential. So is equals to, now we're going to differentiate everything here 10 by 10. So when you differentiate 1, of course 1 is a constant, so it's going to give you 0. Now, as I told you, in a situation you have a product of two functions, we are going to use product true. So don't forget to bring out the sign first, and open the brackets. So hold one and differentiate the other. So holding x to differentiate y. Since y is in the second power, second differential, I'm going to get y to the third differential. Plus, I'm going to hold this one as well, which is y to the second differential, and I will differentiate my x. So if I differentiate my x, I'm going to have 1. Okay, so going on to this one, this is the first power, and this is the first power. So if I differentiate each of them, I'm going to have y to the second power, y to the second power. Okay, then let's consider these two as well. So these are products of two functions. So I'm going to use product two. So as I said earlier, open a bracket, hold one and differentiate the other. So holding, starting from x squared, if I differentiate the y, since it's y to the first differential, I'm going to have y to the second differential plus I'm going to hold y to the third differential and I will differentiate x. So holding that, I'm going to have y prime. Of course, if I differentiate x, I'm going to have 2x. So I'm going to have 2x. Then close the brackets. Then plus. So when you're in a situation that you have a constant and a product, the constant is multiplying a product, you just bring out the coefficients of the product. So looking at it, the bringing of this product is +2. So bring out the coefficients. So when you bring out the coefficients, you open a bracket and still apply your product rule. Hold one and differentiate the other. So if I hold x and differentiate y, I'm going to have y prime. Then I'm going to hold y to differentiate x. So if I hold y to differentiate x, I'm going to have 1. So from here, I have that from my y to the fourth differential, I have negative x y prime prime negative y prime minus y prime prime minus y prime prime. So from here, I have x squared to the second differential plus 2x times y prime will give me 2x y prime. Then from here, of course, 2 will be distributed. So 2 times everything in that bracket will give me plus 2xy prime plus 2y. Okay, so since we have gotten what our fourth differential is, so we need to apply our initial value to this portion. So applying our initial value to this solution gives us that the y of the fourth differential of 0 gives us, remember that x is 0, and of course our y prime prime, so the y to the third prime is 1 minus 2b. So we have that minus 0 times (1 minus 2b). So looking at this 3 differentials, they are alike, so I can 3 of them means minus 3 y prime prime. Okay, so from here our y prime prime is 1 minus 2b, and of course it has negative outside, so I have negative of 1 minus 2b. Okay, so plus our x of course is 0, so 0 squared times our y prime prime. Our y prime prime is negative a, so we have negative a plus, of course, 2 times 0 times y prime. So what is our y prime? Our y prime from here is b. So times b plus, looking at this one, we have 2 times 0. 2 times 0 times y prime. And our y prime is b as well. Okay. Plus 2y. So 2 times. What is our y? Our y is a from here. So that will be 2 times. 2 times a. Okay. So okay, our y prime was supposed to be negative a, not, this was supposed to be negative a. Okay, it was supposed to be negative a, so we have negative a. Okay, so that was the mistake there. So bringing out our whole solution gives us y of 0, of course, is equals to 3a plus 2a, which gives us 5a. So since we've gotten all our conditions, all the terms, so we're going to use each of them to impute in the Taylor series. So we know already from our question that Taylor series, general series of Taylor, gives us y of x is equals to y of x naught plus x minus x naught y prime of x naught plus x minus x naught 2 factorial y prime of x naught plus x minus x naught to the third power divided by 3 factorial of y to the third prime of x naught plus x minus x naught to the fourth power divided by 4 factorial of y to the fourth differential of x naught. This series continues. So from here, the only thing we have to do is to apply the values of these primes, into the series solution. So recall that our x naught is equals to 0. So whenever we see x naught, we should know that our x naught is 0. So let's go. So for the first one that we have y of x naught, it's already given from this equation that y of x naught is equals to a. So the series solution becomes y of x is equals to a. Now to the second one, we have x minus x naught, which is x minus 0. So someone might ask from here, since from the beginning of the video that your x naught, since if you know that your x naught is equals to 0, you're talking about Maclaurin. So why didn't I just write the Maclaurin series? So you just know that either the Taylor or the Maclaurin, and the Maclaurin was derived from the Taylor. So even if you use a Taylor series, knowing that your x naught is equals to 0, you can still get your answer. It doesn't affect it. Just know that all Maclaurin are Taylor series, but not all Taylor series are Maclaurin series. So from there we have that, of course, plus x minus 0, which will give us x. So what is our y prime of x naught? And we know that x naught is also what's our y prime. So that's b. So that will give us xb. Plus the next one we have here is x minus x naught. So from here we know that x is already 0. So what we are dealing with here is only x squared divided by 2 factorial. Then what's our y prime of 0? Y prime of 0, go back to your equation which we have as negative a. So go back there and add negative a plus the fourth term, which is the third power. So that we're going to have x cubed divided by 3 factorial. So what's the value of our y prime prime of x naught, which gave us 1 minus 2b. So this is actually going to be 1 minus 2b. Now to the fourth power, which is our fifth term, what we get there. So looking at here, we have x raised to the power of 4 divided by 4 factorial. So what's the value of our y to the fourth differential, which was 5a? So this is multiplied by 5a t infinity. So writing everything out gives us y of x is equals to a plus xb minus x squared a divided by 2 factorial. 2 factorial means 2 times 1, which will give us 2, plus x cubed minus 1 minus 2b. 3 factorial means 3 times 2 times 1, which will give us 3 times 2, that's 6. Okay, then the fourth one, which is x to the 5a divided by 4 factorial means 4 times 3 times 2 times 1. So 4 times 2, that will give us 24. Everything. So this is the answer to the first question.